Good morning, good afternoon, good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. I'd like to start our event today by thanking Teradata and Hortonworks for sponsoring today's event. Both companies are great supporters of Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and to show our appreciation for some of our other recent sponsors, including Pivotal, Microsoft, Tableau, Oracle, IBM, and Cisco, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you haven't had an opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled Best Fit Engineering for SQL on Hadoop. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We'll have two panelists that I'll introduce in just a minute. There'll be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com in the next few days following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. So I'm very pleased to introduce today's speaker, Mark Shainman of Teradata and Mark Lochbieler of Hortonworks. Mark Shainman is Program Manager for Teradata's alignment with SQL-on-Hadoop engine Presto. And as part of Teradata's unified data architecture team, Mark looks after the marketing, education, promotion, and strategy surrounding the uptake and usage of Presto. Previously, Mark was a global program manager for Teradata's competitive program, including Oracle, IBM, Netezza, and SQL Server migrations, as well as data mart consolidations. He's also advised clients on a wide spectrum of database issues, including total cost of ownership, data mart consolidation, disaster recovery, replication, and security, while assisting with core database product comparisons and selections. Now, Mark Lochbieler has over 25 years of experience in the software industry, and with a significant amount of time spent helping the largest financial institutions in North America plan, design, build, and deploy advanced analytic data-centric platforms. In his current role, Mark works with the strategic partners to incorporate open enterprise Hadoop into their product and solution strategies. Mark has a BS in computer science from North Carolina State University and also holds a Six Sigma black belt. Thanks for being with us today. We're looking forward to your presentation. So, enterprises have increasingly large volumes of structured and semi-structured data generated by all sorts of applications. Much of that data is increasingly find its way into Hadoop clusters for analytics because of its versatility and the economic linear scalability of both data storage and compute. And SQL is still the best option for querying it. SQL is the universal connector to many BI tools and technologies, and the prevalence of SQL skills overcomes the Hadoop skills gap. Forrester recently concluded that organizations need to choose more than one SQL-on-Hadoop tool to satisfy all the requirements. So in today's session, we'll learn about SQL-on-Hadoop best practices, including a brief history of SQL-on-Hadoop, architecture and use cases for both Hive and Presto, and we'll take a deep technical dive, as well as discuss the future of Hive and Presto. So Mark, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Okay, thank you so much, Bill. This is Mark Lochbieler with Hortonworks, and as Bill mentioned, we are very excited. I'm very excited to be here with Mark from Teradata to bring to you this webinar. So let's jump right into it. Here at Hortonworks, we're focused on supporting a modern data architecture in your data center where we're complementing existing and new usage cases with Hadoop. And to that end, providing an open enterprise Hadoop platform with Yarn at the center. And what that actually means is we have the opportunity within a single Hadoop cluster now with Hadoop 2 and Yarn to run batch interactive and real-time streams in different workloads in the same Hadoop. Now getting to SQL, that means that we can actually enable multiple SQL engines on Hadoop. Obviously, SQL is king. What we mean by that is it's the best fit for engineering on Hadoop. The skill set is number one in the market for, obviously, ease of access to data. Most Hadoop sites today are deploying more than one Hadoop in their infrastructure. Here we've got an example of Hive, we've got Spark, Presto, and Apache Drill. But those are multiple engines on running in the same, could be running in the same Hadoop cluster. This is actually encouraged by open source software economics. So the idea of SQL on Hadoop is prevalent. It is the number one tool set to work with data. And I actually coded my first SQL in the late 80s on the mainframe on DB2. So the skill set that's transpired over decades can be used today effectively within Hadoop. And we're going to talk a little bit about that. We're going to actually drill in on two of the engines today. So let's move into a brief history of Presto and Hadoop on the same timeline. Just to give you a background here, in the fall of 2008, Facebook actually open sourced Hive. And that was the beginning of the Hive journey. Hive went GA in spring of 2009. At the same time, around 2012, 6 developers started Presto development. So those are the early days. As we roll through this timeline, Presto rolled out within Facebook in 2013. And then in the fall of 2013, Facebook actually open sourced Presto. Just a little bit further in the spring of 2014, a Hive milestone was reached, and we're going to talk about the Stinger initiative today. And that brought to us speed, scale, and additional semantics with Hive. In fall 2014, two major things happened around Presto. They hit some milestones. They were at 88 releases, over 3,000, almost 4,000 commits. And over on the Hive, in the Hive community, Stinger Next was delivered, the third phase of Stinger Next, which we'll talk about in the presentation today. And one of the most recent here in the spring, two things happened. Hive moved beyond, has already moved by now beyond read-only, and Teradata actually provided the first ever commercial support for Presto in the spring of 2015. So that gives you a basic timeline of these two SQL engines on Hadoop that we're focusing on today. Both organizations realize that there obviously are going to be choices. And so let's talk a little bit about Hive in a little more detail. Obviously, we're able to treat data, and with the introduction of Hive with Hadoop, we're able to treat data as in Hadoop as a table, obviously. And we're able to use standard SQL interface. Let's point out that Hive is shipped in every distribution that's out there for Hadoop, Hortonworks and others. But also realize that the versioning on Hive for each release may be a little bit different from the latest Apache release that's being built within the Apache Hive community. So that's real important to understand. When you're running against Hive and you're looking for the latest feature, you just want to check what distribution what version is within your distribution. Obviously, this ability on Hadoop allows us to quickly find value in raw data. With Hive, we're able to still run at petabyte scale, and that's a real important component within the Hive capability. Also, the goal is compatibility with all major BI tools. So that's real important. That's been an emphasis for Hive and other SQL engines. So that's a quick look at SQL and leveraging a little bit about Hive. Let's actually dive into the architecture today, both comparing and contrasting historically and current. If you look at the light green rectangles on the Hive architecture diagram that we're viewing now, we'll see that today Hive has SQL 2011 support. It's got a great optimizer. It's got a metastore in Hive catalog or Hive metastore, and it also has an execution engine. Actually, multiple engines are supported, row engine historically, and now a vector engine. And also, you'll notice that Hive traditionally had run on MapReduce paradigm, and that paradigm was not efficient enough for interactive query for some users. So the community now has a TES engine, which I'll talk about as well. And the community is also working on the next generation of Hive execution called LLAP. I'll talk about in a second. But introduced with Hadoop 2, we also have Spark. So that's a part of the architecture, and it does have some interrelationship with the Hive architecture. Caching is being leveraged as well, obviously, today. And there's always been text, CSV, JSON, etc. storage for unstructured, and now we've got columnar storage. We've got optimized row columnar files, ORC files, and we've also got Parquet storage. So there's a number of layers to the architecture that support this SQL paradigm, and this is a breakdown of the Hive architecture. Now, the Stinger initiative that I mentioned is actually broken down to provide performance. Obviously, that means faster time to insight and also deeper analytic capabilities. And with the Stinger initiative, Hortonworks was a part of the community Stinger initiative and helped to support that initiative. We were able to bring Hive to the point where it's now leveraging a new file format, ORC, and that gives us high compression. That gives us filter pushdowns as an example, and it is a column-oriented store with predicate and again, filter pushdown capability. That's also coupled with a new execution engine called TES, and that TES execution engine eliminates intermittent read and write to HDFS at breakdown of query at subtasks. So between subtasks of a query execution, there's no longer the need to leverage HDFS as a working set storage. It can stream from one task to the next, which is incredibly fast, much faster than the old way of MapReduce. And we also get a query planner. We've got cost-based optimization within that query planner. We've got the vector engine, which I mentioned before. It's running on the Yarn architecture, which makes it an eco-friendly engine and allows us to run with other batch and interactive and real-time engines in the same cluster. And we've also got a new optimizer. Now, looking at how the community moved on the Stinger initiative, again, there were 3 primary goals. One was speed, one was scale. The community of the Hive community didn't want to lose batch scale, and also semantics, additional semantics. So speed, scale, and semantics were the key. It was delivered in 3 phases in the community. And again, Hortonworks was a very big part of this project. It took 13 months, and we added, the community added 390,000 lines of code. And we were able to accelerate queries from thousands of seconds down to 10 seconds and even lower. So the order of magnitude of execution made it possible to support the BI tools that we mentioned before. So this is a very exciting initiative that was delivered. So let's move on a little bit and look at want to update this slide a little bit. We actually at Hortonworks in the third quarter posted public numbers around 152 new customers in the third quarter of 2015. So that actually run rate gets us over 600 customers working with Hortonworks data platform. And obviously we're one of the distributions out there. And we know that statistically roughly over 80% of our subscription base, over 600 customers, are all using Hive. So that tells you that it's the most active community engine on our platform. We also estimate that 60 to 80% of other Hadoop vendor customers use Hive. And we know that we have over, just from a Hortonworks perspective, we've got our sandbox, which is a single node environment for running and testing out Hortonworks distribution. We have over 200,000 downloads annually, and many folks obviously using Hive there. So it's a very, very active project. So if we take a comparison view between Hive and Presto, there are, if I move to the next slide here, what we see from an ANSI SQL coverage perspective is Presto is giving us ANSI SQL compliance. So if that's part of your usage case or if that's part of your need, Presto does provide that. Hive is, the Hive community continues to work on the SQL compliance, and we do currently have a majority of the subset of ANSI SQL. We have query fault tolerance. That's strong in Hive, and that's less as mature in Presto. From a performance perspective, baseline and improving, the Hive server is excellent, highly interactive. Presto does a fantastic job there. Around optimizers, Hive has a basic cost-based optimizer, and Presto is using a basic rules-based optimizer. Obviously, Hive has a very large, broad-based adoption in the community, and Presto, from a community perspective, early adopters from the world's largest internet companies, so that just compares the two usage patterns in the community. From a platform perspective, we have Hive in Hadoop distributions, as in Hortonworks, obviously, and others. So Hive is really focused on Hadoop usage case, whereas Presto can work across Hadoop, RDBMS, and NoSQL. So that looks at the scope. And around common use cases, in Hive, we're using Hive for ETL reporting and deep analysis. And a great fit for Presto is very high interactive analysis, business intelligence, and cross-platform. So with that said, I would really like to turn it over to Mark from Teradata to carry on the presentation and tell us a lot about this Presto engine that we're hearing so much about. So, Mark, can you take over from here?
Sure thing, Mark. Thanks, Mark. So what I'm going to really try to do is give you an overview of Presto and kind of dive deep into the underlying architecture and technology and really where it fits in within your architecture and use cases within your environment. Presto, which means fast in Italian, was, as Mark showed, was built out by Facebook. They needed something that was much more high-speed interactive. And when they built out the solution set, they took much more of a traditional RDBMS type mindset and architecture so when they built it out. So they built it all off of a modern code base in Java, and really the basis of it is for interactive querying. And also cross-platform query capabilities, and I'll get into that in a little while. And so that was one of their main strategies for building out the Presto solution set. And when you really look in the market right now, unlike Hive, which has been around in the market for a long period of time and has a larger base of users, Presto is just emerging in the market. But there's some really big leading companies who are leveraging Presto today within their architectures. That being Facebook, Netflix, Airbnb, Dropbox, Groupon, Gree, etc. are some of the companies who are leveraging Presto extensively within their architecture. So when you look at the Presto licensing model, unlike Hive, it's really not an Apache project. It's actually just under the Apache license. So at this point in time, it doesn't go through the whole Apache development, consensus, collaboration, and governance process at this point in time, which could be an advantage. So it has an ability to develop a little more rapidly. But that's not saying in the future it might not become a full Apache project. But at this point, it's licensed under the Apache license and follows that licensing model. So when it comes to Presto, when Facebook built it out, now the contributors and Teradata being a contributor to the code base, the goal of the engine was query execution performance on data that exists within Hadoop or other database platforms or other data stores. So the whole architecture is based on in-memory processing. And the executions are pipelined across all nodes in a very MPP style, so much more on par with the MPP database type architectures. It does things to improve speed, such as vectorized columnar processing, and it's a multi-threaded execution, keeping all the CPUs and cores busy within the cluster to optimize performance. And as I mentioned earlier, Presto is really written in highly tuned Java. The basis was, let's try to get as much speed and performance out of this engine as possible. So it leverages efficient flat memory data structures. When Facebook actually built out the code, they did very careful coding of the inner loops to optimize performance, and it does runtime bytecode generation to really take advantage of the processor. One of the other things that Presto has, it has its own ORC reader. So it has the ability not only to leverage the ones that exist within the Hive environment, but leverages its optimized ORC reader as well to really optimize performance when leveraging ORC files within a Hadoop environment. Parquet optimizations are coming too as well. And so when you think about the use case for Presto, the real use case when it comes to query execution is this interactive type workloads. When you look at something like Hive, Hive is dynamite. Strength is petabyte scale batch. It is the engine that is awesome at that. So depending on what your specific workload within your environment or your use case, one engine or the other engine coexists very, very well within an architecture. Just to go on about the Presto memory-based architecture, all stages are pipelined, as I mentioned earlier, and it really reduces wait times because everything is pipelined. one thing to take into consideration, because everything is in memory, unlike Hive, if there is a failure within a query while a query is being executed, there's no restart capability within that. There's no checkpoint within that query that you have to actually restart that query. That's why something like a large batch job is much more suited for an environment like Hive versus an interactive workload is much more suited, or is one that can suited very well for a Presto environment. And it does things, as I mentioned earlier, it does memory-to-memory transfer. There's no disk I/O. Of course, when you have a full memory-based architecture, all the data chunks must fit into memory. So here's going on to a little bit more about the Presto architecture. If you look at this, it looks very similar to a traditional MPP type environment or MPT type database, something like a Greenplum or Netezza, because what you have is you have your main coordinator node, and then you have multiple worker nodes that actually do the work. Within your coordinator node, you have a metadata API that basically knows where exactly where the metadata surrounding those tables are, and the location of the location API. So where are those tables located? Are they located in on ORC files within a Hive Hadoop environment? Or are your tables located within a MySQL environment or a PostgreSQL environment? And so the coordinator nodes can have multiple data sources that it's aware of, and data locations that it's aware of as well. And then your worker nodes are, as I mentioned earlier, they actually do the work and would do the aggregation, etc., associated with the data and executing a query. So one of the big differences between the Presto SQL-on-Hadoop engine and many other SQL-on-Hadoop engines that are in the marketplace is that it has these extensibility plugins. When Facebook built out the engine, one of the key components that they wanted within this engine is not only the ability to be able to query data that exists within a Hadoop environment, but also the ability to leverage this SQL query engine to query other data sources as well, such as MySQL, PostgreSQL, etc. So one of the great things about the Presto engine is its extensibility. Not only can it query that Hadoop data, it also has the ability to query other data, such as traditional relational data stores, as well as maybe a proprietary data store as well. And what we've seen within the community is, of course, there's the larger community-based adapters that have been being built out, as well as individuals sometimes can build out adapters that they want to use within their environment. So it's a very, very flexible engine in its ability to actually query other data sources, not just HDFS data. So here are some of the plugin connectors and file formats that Presto actually supports. It's, of course, it supports HDFS and HCatalog. When Presto is querying data that exists within Hadoop, it actually leverages the Hive metastore as its metadata repository to understand the metadata and what tables exist within that environment. So it actually, in a way, works in conjunction in a Hadoop environment with Hive. So the great thing about it is, if you have existing tables that you've already created within your Hadoop environment leveraging Hive, Presto has the ability to query those tables as well. As I mentioned, it has the ability to query ORC, ORC, RC files, Parquet, sequential files, and text files as well. When it comes to other platforms that it actually has the ability to reach out and query, MySQL, PostgreSQL, S3, Cassandra, Kafka, and Redis as well. Right now, there's a number of other connectors that are being built out by the community. MongoDB, Elasticsearch, and HBase as well are some other connectors that are being built out within the community. So you can see that the Presto engine is very extensible, and the scope of the platforms that it's able to query is continuing to increase based on community input. So one thing, as Mark mentioned earlier, the goal when Presto was built is for it to be ANSI SQL compliant. So when you're executing queries within Presto, you're executing ANSI SQL. There's no leveraging of something like Hive QL. It is 100% ANSI SQL. So the engine includes and supports standard SQL data types. It also supports other data types as well, such as JSON, array, map, etc. The engine has analytical functions that it supports as well, windowing functions, statistical, approximate, aggregation functions. All that type of functionality is actually supported by the Presto engine, and it's the SQL functionality within the engine continues to improve and continues to increase release to release. That's one of the goals, is to continue to add to the engine and make it that ANSI SQL compliance of a very, very robust ANSI SQL functionality within the engine. But as I mentioned earlier, one of the great things about it is you don't have to know any other type of proprietary language to execute queries within Presto. It's just ANSI SQL, and that's it. So one of the things that Presto does have the ability to do, which is pretty neat, is because it not only has the ability to query Hadoop data, but other data platforms, it actually can do push down into those other data platforms depending on what connector it's actually utilizing within that, within its architecture. So for most connectors, it simply pushes down predicates into the data source. So for example, let's say you're querying a Postgres database, something like select average column for Postgres table, where Postgres table column is greater than 10. Presto will actually push the component of select column from Postgres table, where Postgres table is greater than 10, down into Postgres, and then the average column part of the result will handle that component when it's returned from Postgres. So it's a great functionality within the engine, is it can push down that predicate into those other platforms and then do the aggregation within the Presto engine. So it has that functionality within the engine, which is great. One unique thing about Presto, it has multiple deployment models. So for example, you can deploy on-premise within the actual, your actual data center. It can deploy it in a cloud, such as in Amazon, and it can be deployed on a VM image as well. When it comes to Hadoop deployment specifically, it can actually be deployed on the nodes itself, the Hadoop Yarn cluster, or a subset of the nodes. We see organizations who are leveraging it in that manner, so it actually lives on the Hadoop nodes, or it could be on a dedicated cluster with enough network bandwidth. Or it could be mixed. So we've seen ones where 2 Presto nodes per cabinet and the rest are Hadoop nodes. Or, for example, if there's a specific environment where it's just querying something like MySQL, you can actually have a dedicated cluster that connects to MySQL and then queries to MySQL and doesn't even live within a Hadoop environment. So it has multiple deployment models based on the specific use case or performance that's needed for that use case. So Presto is, we see in production at scale at many of the leading internet companies today. Of course, Facebook, who actually built out Presto, has multiple Presto environments. a number running on Hadoop and other ones running on MySQL, and one actually running against a proprietary data store, columnar data store that they built out as well, all leveraging Presto as the query execution engine. So in Facebook, they have multiple production clusters, 300 petabyte Hadoop data warehouse that they're actually leveraging Presto against. As I mentioned earlier, they have a large sharded MySQL installation that they're leveraging Presto as the query engine against. And, they have thousands of daily activity users, millions of queries a month, and, trillions of rows a day. So it's really interactive workloads at petabyte scale Facebook's been leveraging Presto at. Netflix is got a 200-node production cluster in EC2, 25 petabytes in S3, and 350 active users with 3,000 queries daily. So you see there's some scale that organizations are actually leveraging Presto as a query engine. SQL-on-Hadoop as also querying other database platforms within their architecture. So Teradata specifically, as mentioned by Mark, at the beginning of the year, we basically came to the table and said we are actually going to be a major contributor to Presto, the Presto code base, and are offering enterprise support for Presto. So some of the key components that we're actually offering on our have mapped out on our roadmap to really try to accelerate the adoption of Presto and the usability and functionality of the engine has been these three phases. So at the beginning of the year, we actually built out an installer to make it much more easy to install the Presto software. We had created some deeper documentation, some monitoring and support component, and some tools surrounding the actual engine. Phase 2, which we're actually delivering at the end of this year, is a major enhancements to the Presto platform that we're making available. We're making Yarn integration available, so now Presto will actually run within a Yarn container, be able to be managed by a Yarn, some management tool integration. And one of the things that Presto was actually lacking was a really good, robust ODBC and JDBC driver. There were a couple drivers that were out there that were developed. One was community developed, one was developed by Facebook, and they just weren't very robust and stable. So we basically said, hey, if the community, one of the big community needs is so all these BI tools can very easily integrate with Presto and effectively integrate, we need robust ODBC, JDBC drivers. So we ponied up and are delivering at the end of this year, an ODBC driver that's built out enterprise class ODBC driver, and at the beginning of 2016, we're also delivering JDBC driver as well. We've also been working with a number of our BI tool partners, such as Tableau, MicroStrategy, ClickView, and to certify their BI platforms on top of Presto as well. So we're really trying to advance the functionality, usability, and robustness of Presto so it can have a wider adoption within the enterprise. And Teradata is completely committed to enabling this and helping the engine along as well. So one of the other things we're delivering is called a Teradata Query Grid Connector for Presto. And just a little background so you can understand what Query Grid is. Query Grid is an architecture that Teradata built out that enables components within the Teradata unified data architecture to be able to interact and query each other. So you can run the right analytic on the right platform, and it minimizes having to move data from one platform to the other when you're actually needing to query. So it actually enables you to execute a query, say, from a Teradata data warehousing environment, and that query to reach out through Presto to Hadoop and answer that query. So a representation of that would be our Query Grid connector, which is coming out at the end of the year for Presto. Let's say a customer has an existing Teradata platform. They're able to query to Presto, which can then reach out to Hadoop, Cassandra, MySQL, PostgreSQL, etc., and join that data with data that exists within their existing Teradata data warehouse. Also, you can then query from Presto as well if you're working on Hadoop or MySQL and reach out to your Teradata environment and actually pull data into Presto and join that data as well. So it's just an extension of the ability to actually use the right platform in the right place when you're actually querying data, and let it be able to be joined with data that exists within your traditional relational data warehouse, your Teradata relational data warehouse. So here's just a larger architecture of the Teradata query grid with Presto, where you can see that we've built out all these connectors that exist to all these other platforms. So I'm able to query from Teradata to Astrodata, Teradata to MongoDB, etc. And then now with the Query Grid connector from Presto to Teradata, I can actually join data in my Teradata data warehouse, join data from Astrodata, from Oracle, from Presto, that also reach out to MySQL, PostgreSQL, Cassandra, etc. One thing that I did mention is, Teradata, we're fully committed to, to advancing and being contributors to the Presto open source solution, and we actually have a team of 20 dedicated engineers that all their job is developing code and improving and advancing the code, the open source code for Presto. And we're really positive on the Presto platform, the functionality that it brings to the community, the Hadoop community as a whole, but also its cross-platform capability. We really think is a value proposition to numerous existing Teradata customers and then other customers, within the marketplace as well. So we're really, really positive on that. And one of the other benefits that having, such a large group of people that are developing code for the Presto platform is that we're able to offer very, very deep enterprise support for Presto. So now organizations can actually get support and be able to call up and say, hey, I have a problem, how do I fix it? And we're actually able to deliver on that. So that there's open source releases of Presto come out probably every 2 to 3 weeks. They're available on GitHub. But, just like any other open source solutions that are put out continually, many of them are unstable. And a lot of them actually have experimental type functionality in them, and they're good to test on, but they're not actually always the best if you're running a robust production environment at scale. So what Teradata actually does, we actually offer certified releases of Presto. They appear about every 3 to 4 months, and we go through an extensive process of, bug check, stabilization, feature add, etc. And then we make those available on Teradata.com/Presto, those actual releases. And we go through a rigorous testing process, and then because we've gone through this testing process, we're actually able to offer, support for those. So an organization can purchase support and then call up and say, hey, I'm having this functionality problem with my environment. Can you help me out? And we can say yes, because we were actually gone through this robust and stabilization process. So when it comes to the support for Presto, right now Teradata is the only commercial vendor offering global services and support for Presto. We've been offering support models for analytical platforms for years and have an existing infrastructure in place. So we have, experienced, trained staff who can offer this type of support, as well as, the support is coming from an organization that actually is one of the larger contributors to the actual Presto code base. So we have that advantage as well. And we have, as I mentioned earlier, we have a lot of deep knowledge when it comes to BI workloads and data warehousing and analytical workloads, which we bring to the table because we've been doing that for years and years. And this is one of the advantages that we offer is organizations can now leverage Presto within their enterprise and get the type of support that they're accustomed to, for their data warehousing environment. So for organizations to find more, for you or anybody else to find more information on Presto, and I highly advise you, you too, we think it's a great platform. We also realize that organizations are going to leverage other platforms, like Hive is a great platform, Spark for its specific workloads is a great platform. But if you're interested in more information surrounding Presto, this is a great information you can find both at on the GitHub is the Presto actual releases that I mentioned, those experimental, the 2 to 3 week kind of releases. The Presto user group on Google Groups is a great resource to find information surrounding it. Of course, on teradata.com/Presto, not only can you download a copy of the software, there's also documentation and other information surrounding the Presto platform. There's a great Facebook page as well on facebook.com/Presto, and there's the Twitter handle as well. So I hope in this short period of time that I tried to cram a lot in, that I gave you kind of an overview of what Presto can do as a query engine, being able to interactively query Hadoop data as well as other data sources such as MySQL, PostgreSQL, and Cassandra, and where Teradata as an organization really think we can contribute to the open source community and the open source code base and improve on the Presto platform. Okay, and now back to you, Bill.
Okay, well, hey, Mark S. and Mark L., thank you so much for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation. We'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this screen, which has the contact information for both of our presenters, should you want to get in touch with them directly following today's webinar. So let's get started. Let's start with a fairly basic question. For example, can I use Presto to join data across multiple data sources, for example, between Hive and Teradata?
Yes, you can. As I mentioned earlier, Teradata is releasing at the end of this year Teradata Query Grid Connector for Presto, which will enable the capability to query from Presto to Teradata and join that data within the Presto environment, as well as Presto as a query engine itself outside of the Teradata environment has the ability to join data. Say, for example, I can have, within a single query, I can actually query and join data that exists within Hadoop and join the data that exists within Cassandra and join that data within the Presto platform. It has that ability as well.
Okay, well, thank you for that answer. Now, a lot of questions have come in asking for comparisons of Hive and Presto with other tools. So let me just list these tools that the folks would like to hear comparisons to, and they are Drill, Impala, and Hawk. Can you speak to that issue, comparing Hive and Presto to those other tools?
Mark, did you want to touch on that?
Sure. Let's talk. I'll compare Hive being a community approach to Impala. Impala being open source but not community based. The strength there with Hive would be petabyte scale batch, and also having the open community behind it, and things like Stinger Next. So that's one example versus Impala, which has a in-memory, originally an in-memory limitation, and it's really well defined within distro, but not across the community. So that's one example. With Hawk, there's a community around Hawk who actually came to Hortonworks and said, Hortonworks, can you certify Hawk on HTTP, Hortonworks Data Platform? And this actually brings up my biggest point here. At Hortonworks, our strategy is Open Enterprise Hadoop with Yarn and plugging in multiple engines. That would be Drill. That would be Hawk. We'd welcome Impala to join as well. But we're open to community choice on SQL. So whether it's Hawk or Hive, whether it's Drill, we're not going to not support those open community engines and also commercial engines that want to play in there. So I'd like to turn it over to Mark S. to get his opinion on Presto versus some of these tools specifically, because Hortonworks is very agnostic when it comes to which SQL engine.
Right. And as I do have to mention that Teradata is, of course, we're behind Presto, and we believe Presto is a great query engine and how it was built out and its cross-platform capabilities. But we realize that our existing Teradata customers are leveraging, Impala and other query engines as well, and of course we support those within the overall Teradata architecture. That's being said, when we look at, for example, Impala versus Presto, they're very similar in a lot of cases. They're very, they were built out as, in-memory based SQL query engines. One of the advantages that the Presto sometimes brings to the table, of course, Facebook says this, is that the scale at what it can run at and its scalability is, in some cases, they believe higher than what the Impala platform runs at. So that might be one of the differentiations. One thing that we always recommend is, hey, one of the great things about having all these engines available, and the great thing about Presto is that you can download it and test it. One thing to also understand is that Impala is not going to run on top of ORC. It doesn't support it, and that's one thing that the Presto does support and has the ability to leverage ORC, and Impala does not. So there's depending on Parquet versus ORC, what you're running in your environment or can run within your environment. One thing that's about Presto as well is it's not really tied to any specific distribution. It's not like Impala with Cloudera, even though Hortonworks, who is our partner that we're talking to today, the great thing about Presto as an engine, it can run on MapR, it can run on Horton, it can run on Cloudera. It's very platform agnostic when it comes to the underlying platforms that it can run on. As well as I mentioned earlier, one of the big differentiations between Presto and some of the other engines is that it can join data that exists within a MySQL database and within HDFS environment within a single query within the engine, which a number of the engines can.
Well, those were terrific answers and a great comparison. And now a number of questions want to just focus on Presto and Hive, and specifically a comparison. So let's do it this way. What are the best use cases for Presto and best use cases for Hive?
Well, when it comes to Presto, the best use cases are really your interactive type queries and workloads. If you have, BI tools and users that are interactively wanting to query data that exists within your Hadoop environment, and that's where Presto really shines. Another use case is if you really want to do queries across multiple data platforms. So, for example, I want to query not only data that exists within my Hadoop environment, but I have the ability, the need or want to join data that exists in some other platforms, such as a proprietary data store, or such as Cassandra. And then that's a great use case for Presto as well. One of the use cases that Presto is not great at would be very, very large batch workloads. And I believe, Mark can talk about that's where, Hive really shines.
Yes, that's exactly what I was going to say, Mark. Thank you. I was going to basically say Hive has the absolute sweet spot for large-scale batch. So we'll leave it at that for that question.
Terrific. Terrific. Okay, so here is a more technical question, because obviously you've got folks' attention on how to use Hive and Presto. So what is the recommended deployment model for maximizing performance?
Of which platform? For Presto, as I mentioned, okay, for Presto there's multiple deployment models depending on what your environment looks like. For example, at Facebook, they actually, within their Hadoop cluster, they have 2 dedicated nodes that they actually run Presto on, so they can utilize all the memory because Presto, of course, is an in-memory engine, so they can leverage all the memory and CPU dedicated within those 2 nodes within their Hadoop cluster per rack, and that's how they leverage it for their petabyte scale environment. But it all depends on what your specific use case within your environment. It can coexist within the actual Hadoop nodes, or you can have a dedicated node within the Hadoop cluster, or if you have enough network connectivity, you can actually have a dedicated cluster. It all depends on the specific use case. But one thing, like any engine that leverages memory, the more memory that you have that it can leverage within that environment, the more performant that engine is going to be.
And Mark, if I may add on the Hive side, there's different, with Hadoop 2, we actually have the ability to run the Hive server on Yarn, and on Yarn we have 2 execution engine options. One is MapReduce, one is TES. And for certain workloads, the TES engine will give that in-memory interactive, a little bit more interactive speed. So the optimization around not large-scale batch, but some in-memory would be Hive on TES with ORC. That's an example for a specific workload. We still have a ton of customers running the MapReduce large-scale batch. So you really have to look at the workload, but there are multiple options in that architecture today.
Oh, and
Terrific.
One thing that I did mention about Presto is that Presto's highest level of performance is going to be on ORC as well, just like Hive.
Okay. Well, hey, thank you both for those great answers and comparisons. We've got time for just a couple of technical questions. Let me start with, what versions of Hortonworks data platform are supported by Presto?
Oh, that's a quick one. HTTP 2.2 and 2.3.
Terrific. And from an operating perspective, if we're using, say, Apache Ambari, can Apache Ambari manage Presto?
So we're targeting that for Q1, early next year, 2016.
Okay. And we had a question from the audience that asked whether or not Presto would work against an AVO file.
It does not support AVO File at this time, but it's something that we're looking to do in the near future that the community is working on.
Okay. Well, hey, thank you both for some great answers to some very good questions. And for those of you who have asked questions that weren't answered today, we'll be sending all the unanswered questions to both Marks and the teams at Teradata and Hortonworks so they can follow up with you after today's webinar. I have just a few quick announcements. First of all, if you'd please mark your calendars for December 1st, and the next Data Science Central webinar, which is Jump Over the Data Preparation Hurdle with Spark, and that's going to be sponsored by Platfora. Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of datasciencecentral.com in the Webinar tab located at the top of the page. So this brings today's webinar to a close. I'd like to thank our audience for their attendance and their thoughtful questions, and a special thanks again for Teradata and Hortonworks for their sponsorship, and our speakers today, Mark Shainman and Mark Lochbieler, for their insights into today's topics. So my name is Bill Voorhees. I'm very pleased to have been your host today, and I look forward to seeing you all again on December 1st. Have a great day.